Here I have a subassembly associated with an industrial robot, and my goal is to calculate the natural frequencies for this subassembly. So first thing I do is go to Simulia Structural Validation and select from the three different simulation types: structural, frequency, or thermal. In this case I select frequency to create the starting point for defining my frequency simulation. And we can see that there's not much that's required before I can run simulate. In fact, I could run the simulation immediately. I have all my parts, 7 parts included. All these components have materials assigned. Connections between the parts are optional, as are restraints. Now, I actually do want to define some connections. I want to bond everything together where they touch, so I hit the Find Surface Pairs option, and you can see it found all these different touching locations. I can accept these, and now I have bonded connections between all of those regions. I also want to define some restraints. So I need to have a few ball joint restraints in this simulation, so I'll define one here and here. And on the back face I'll define an individual ball joint restraint, selecting both of these regions together. Okay, now I have all the restraints that I am interested in defined, and next thing I could do is run the simulation. To do that, I go to the results action part of the action panel and run the simulation. I have a few options here. The most straightforward is to simply grab the first 10 modes, and I can run this on 2 cores. And now I'm running the simulation. The simulation is now complete, and I can look at the results. The results that I can view include displacements, deformation, and displacement vector. And vector shows a visual indicator of the distance that an individual node would travel. If I want to look at the deformation, I can look at that for any of the top 10 modes that have been calculated. You can see we can step through these various modes in either the deformation view or the displacement view or the displacement vector view.